Hello friends, welcome back to my YouTube channel. Welcome to my discussion on tall columns. This is part number 5, and in this I'll be talking about analysis of stresses induced in the wall of a tall column due to eccentric loads. In my earlier videos I have discussed analysis of stresses due to uh, dead loads and then wind load. And now let us understand how to analyze stresses that are induced due to eccentric loads. So at the end, we will be adding all the stresses or stresses due to all the loads for the ultimate analysis. So I'm giving links to my earlier videos in the description section. You please watch them. So for now, stresses induced in the wall of a tall column. Let us begin the discussion. Stresses due to eccentric loads. First, let us understand what are the loads that have to be considered in this analysis. So loads due to which stresses are induced. You have internal pressure, external pressure or vacuum. These may also result in stresses in the wall of the cell. These stresses may be longitudinal, that is acting in axial direction, or they may be circumferential or hoop stresses. Okay, so you can have stresses in axial direction, stresses in circumferential direction due to these loads, internal pressure or external pressure or vacuum. What is the nature of these stresses? These stresses are both tensile and compressive. They could be tensile and they could be compressive. Then I have already discussed about the stresses in my earlier videos. You please watch those videos. Then you have to consider dead loads. So these dead loads, they are going to produce axial stresses in the wall and they will be compressive in nature. Then you have wind loads. Again, they are going to produce longitudinal or axial stresses, and this will be tensile and compressive. Then eccentric loads. This are going to produce longitudinal stresses, and they will be bending stresses. The resulting stresses will be bending stresses. Then we also have to consider seismic loads. Wherever you have chances of earthquakes in those areas, if you are installing the tall column, you have to consider seismic loads also, and they are going to produce axial, that is longitudinal stresses, and they can be tensile and compressive. So today we are going to discuss about eccentric loads, how to take care of stresses that may be induced due to eccentric loads. So this is the objective of this video. Let us first understand what are eccentric loads. So I have shown a simple schematic of a tall column, tray column. So you can see there are various elements associated with this column. You have platform, you have ladder, railing, manhole, trays inside the column, downcomer, skirt support. Now let us understand what are the eccentric loads. So eccentric loads are the weight of externally attached equipment and parts. So these are weights of externally attached equipments and parts. So for example, you have ladders which are externally attached to the column. Then you have pipes, manholes, overhead and side condensers, platforms. So these are all examples of externally attached loads, and these externally attached loads, they are going to produce they will be acting as eccentric loads, and they can result in stresses in the wall of the shell. ठीक है. Now let us know what is eccentricity. ठीक है. So if you have load W, then for this load its eccentricity is you can define it as the distance between the column axis and the line of action of that load W. So for example, if you represent a column by this simple rectangle, and if this is the central axis of the column, and if load W is acting over here, so as per definition, distance between this line of action and the axis of the column will be eccentricity for this load. So it will be E, the distance between the line of action of the load and axis of the column. That will be eccentricity for this particular load. Now eccentric loads, when you have such eccentric loads, this eccentric loads, they will produce bending moment. Eccentric loads produce bending moment, and in this bending moment, how to get this bending moment? For example, for this case, for W with an eccentricity of E, the bending moment is given by this equation. ME is equal to W into E, bending moment. And if you consider all the loads, all eccentric loads, then you will have to add those bending moments. So you'll have summation of bending moments due to each of the load. So for load W1, it will be W1 into E1 plus W2 into E2 plus W3 into E3, and you have to go on adding all the loads, all the eccentric loads. So the point is you have to get total bending moment, and this total bending moment then will be used for finding out the stress that will be induced due to those eccentric loads. So the bending moment, once now we know bending moment will be produced by eccentric loads, and this bending moment is then going to produce bending stress. So we are going to understand that. Now let us know what is the bending stress due to bending moments. So if you consider a plane at a distance of x from the top, now the distance is selected in such a way that for that particular distance the thickness is uniform. If you are selecting a plane at a distance of x, then thickness has to be uniform above the selected plane. So if you, for example, if you look at this diagram, so I have considered this distance from the top. Okay, so within this distance, the thickness of the cell is uniform. We have selected distance in such a way that thickness of the shell is uniform within this region. Okay. So the total bending moment due to all eccentric loads, they induce bending stress at the plane X, and this bending stress is given as FBE. Bending stress due to eccentric load is equal to 4 into summation of ME, that is summation of bending moments due to all eccentric loads, divided by pi into di plus ts into ts into di. So this equation you can use for finding out the bending stress, or the bending stress that will be induced due to eccentric loads. Okay, most of the time you can neglect this stress. If you compare this with stresses due to other loads, this can be neglected. So in my future analysis, I'll, I'll I'll be neglecting this uh, in the analysis of all the stresses. Okay. So this is how you can get bending stress that is induced due to eccentric loads. So the point is eccentric loads produce bending moment, and bending moment results in bending stress, and this bending stress is given by this equation. Okay. So with this I end my small discussion on stresses that are induced due to eccentric loads. Thanks for watching. Do subscribe to my YouTube channel. In my next video, I'll be continuing my discussion on tall columns. So be with me. Thanks for being with me. Do subscribe to my channel. Do like my videos. Hit the bell icon so that you'll be notified as soon as I upload any new video. For now, thank you for being with me. Have a nice day. Bye bye.